All right, so we're going to go ahead and continue with the assignment number 2. This is the second video for that. So we have this tolerance situation. Tolerance situation is something where we're going to, let's say we're going to produce basketballs. They're supposed to be somewhere between 29.5 to 30 inches. So maybe 29.75 is what they're supposed to be, but if there's 29.5 or 30, then it's okay. The circumference, then we're okay to pass it forward. But if it's 31 or 28 inches, then it would not meet the regulation size, and so we would have to throw that away, and it would be something we'd have to start over with. So we're going to write this tolerance 3 different ways, and the first one is simply with a compound inequality. And so a compound inequality would look something like this. The circumference of the basketball, I'm going to call that n. Well, that has to be less than or equal to 30 inches, but it would also have to be greater than or equal to 29.5 inches. And so that's writing it with a compound inequality. We could also write this with plus and minus signs. So if I said that I really want the basketball to be 29.75 inches in circumference, plus or minus the difference that it would take to get me to 30 or to 29.5, which is 0.25 inches, or 1/4 of an inch. So I could have phrased this question as this. The regulation circumference of a basketball is supposed to be 29.75 inches. But if you're off by 1/4 of an inch, then we're okay. Then we're all right. If we're off by more than 1/4 of an inch, then that's an unacceptable size basketball, and we'd have to throw those basketballs that we produced away and start over and create ones that are within the regulation size. The third way to do this is with an absolute value inequality. Let me show you how this works. I could say the absolute value of the circumference, I'm going to say n minus what I want it to be, which is 29.75 inches. So the distance from 29.75 inches has to be within less than or equal to 0.25 inches. I could just write it like that. Here's why this works. If I'm going to rewrite this equation, it would look like this. I would have n minus 29.75. Well, if I write this as 2 separate equations, that's going to be less than or equal to 0.25 and greater than or equal to negative 0.25. The reason it's an and is because it's less than. And so if I write it like this and I solve this equation, what I'm going to end up with is my compound inequality. I'm going to add 29.75 to all 3 sides. The middle, the 29.75, will just cancel out. If I take 29.75 plus negative 0.25, well, then I'm at 29.5. And if I take 20.25 plus 29.75, well, then I'm at 30. So you can see that these 2 things mean the exact same thing. We're just writing it as a compound or as an absolute value inequality. So let's take a look at a situation and see if you can write this situation as a compound or as an absolute value inequality. The circumference of a bicycle tire is supposed to be 113 inches, give or take a 1/2 inch. So maybe it's too much inflated, maybe it's too much underinflated. But it would look something like this. The absolute value that we're looking for is going to be x minus 113. Then we want it to be less than or equal to a 1/2 inch, which is 0.5. If we were in math space, it would be 0.5. And that's how we would leave it. The reason this works is because this means the same thing as x minus 113 is less than or equal to 0.5 and greater than or equal to negative 0.5. So when I added 113 to both sides, I'll have x is less than or equal to 113.5. That's the biggest it could be. And if I take 113 and I subtract 0.5, well, I'm at 112.5. And so I'm looking at my bicycle tires that are within that range, which is described as an absolute value inequality like this. So those are the tolerance equations. That'll also be in your homework. And so we'll have you work on that, and we'll see you tomorrow in class.